We're going to look at a few examples of problems that we have to solve by multiplying one or both equations. In fact, I think we're going to try and just keep it down to where we're multiplying only one. So I want you to take a look always at the coefficients for each variable. In this case, let's take a look at the two coefficients for x. You've got a 2 and a 5. And the only way you could get rid of those is if you could turn one of them into a positive 10 and the other one into a negative 10, because 10 is the lowest common multiple of a 2 and a 5. And I don't really want to multiply both equations, especially when I have an easier way. The number in front of the y is a 1, and this one is a 3. So this actually is a negative 1. And I can make a negative 1 into a negative 3, and that's going to make it cancel out with this positive 3y. I've already got opposite signs. I've already got right there, I've already got a plus and a minus. So I'm just going to multiply the top equation by 3. And what that's going to do is it's going to turn the coefficient on y to a negative 3y, and this is already a plus 3. So they're going to cancel out. So let's multiply it out. 3 times 5x, because we got to multiply every term. If we don't multiply every term, we're going to get something that doesn't work. Minus 3y equals, and 3 times 28 looks like it's going to be 84. And I know that that's not the most friendly number. It's a little bit on the bigger side, but what the heck. 2x plus 3y equals a measly 1. And if I add these up, you'll take a look. The minus 3y and the plus 3y are going to go away. So that's going to be a 0. And I've got 17x plus 0, and that equals 85. And isn't that special? So when I want to solve this equation, 17x equals 85, if I divide by 17 on both sides, 17 goes into there and even 5 times. So if I were building my solution, x is a 5. And now we got to go find y. It doesn't really matter which one we plug it into. I'm probably going to just plug it into the bottom one simply because everything in there is positive. So 2 times x is going to be 2 times 5 plus 3y equals 1. And that's 10 plus 3y equals 1. And this is going to work out okay. We'll get rid of this. This is a two-step equation at this point. We have 3y equals negative 9, and then I divide by 3, and I get y is a negative 3, and there is your solution. I got 5 comma negative 3. Here's another equation where it's kind of obvious which one we got to get rid of. The number in front of the x is a negative 1, and so I've got a negative 1 and a positive 5 to work with, and I'm drawn to the idea that this is already negative, and the 5x is a positive. So that looks like the easy way. The other option would be to get rid of the y, and the only way you can get rid of a y when there's a coefficient of 2 and 11 would be to turn them both into a 22. I don't really want to multiply both equations, but if I did, I could multiply the top one by an 11 and a bottom one by 2. And that would give me a negative 22 up there and a positive 22 up there. It's not what I'm going to do. I'm going to get rid of the x's. This is a positive 5x, so I need this to be a negative 5x. It's already a negative 1, so I'm just going to multiply it by 5. So I'm going to copy down the bottom equation first, 5x plus 11y equals negative 2. But I am going to take this top one and multiply it by 5. So 5 times negative 1, that's a negative 5x, and those are going to cancel out. And then I got 5 times a negative 2y, that's negative 10y. And 5 times 0, last I checked, still 0. And there we go. I have the x's, I'm just going to highlight them in pink. Those are going to go away. So I'm not going to put a 0 down here, but it is a 0. Here, I'll put a little 0 for you. And this becomes a positive 1y. 1y is equal to negative 2. I don't have to do anything to it. Y is a negative 2. So when I go to build my ordered pair, there's my y. Oh, I guess I'll do this in this bottom one here. I got 5x plus 11y, but in place of y, I'm going to put what y was, which was a negative 2. So I'll put the negative 2 there. Equals Negative 2. Let's go ahead and solve it. I got 11 times a negative 2 is negative 22. So I got 5x. We're not going to write plus a minus 22. Just write 5x minus 22. Over here is a negative 2. And so now we're 2 steps away. So we're going to add a 22 to both sides. That's going to isolate 5x. And 22 take away 2 is 20. We'll divide by 5. And we'll get x is 4. So there we go. Our final ordered pair solution is at x is 4, y is negative 2. And oh my goodness, I think somebody sat around late at night trying to figure out how to torture kids with systems of equations problems. And let's take a look. I got a half and I got a sixth. I know I can turn a 2 into a 6 by multiplying by 3, but since the 2 and the 6 are in the denominator, it looks like I'm going to have to multiply by 1 over 3. I'm going to put the 1 over 3 here so that I don't run out of room. But I also notice that if I do that, 1/2 times 1/3 will be 1/6, but it's going to be a positive still, and this is already positive, so I need it to be negative. So that's what I'm going to have to multiply by, and I'm just paying attention right now to the fact that I got a negative sign there and a negative sign there, and a negative sign that I'm multiplying by. So I'm going to have a couple of positives, got some things that are going to switch. Let's keep the bottom one the same. Holy smokes. 1/6 x minus 1/3 y equals 2/3. Of course, there's other ways to do this problem, but this one seems like it makes the most sense to me, and I'll show you a different way in a minute. That's going to be so we're multiplying the top and the bottom. So 1 times 1 is 1, and then 2 times 3 is 6, but it's a negative number. So that's where our negative 1/6 x comes from, and those are going to cancel. I've got a negative times that negative, which is a plus. And 1 times 1 is 1, and 4 times 3 is 12, so that's plus 1/12 y equals, and that's a negative times a negative, which is a positive, and that's also 1/12. So I'm going to just, oh my goodness, what a nasty looking problem. Before I do this, I might as well get some common denominators here. This is 2 over 3, and I'm going to multiply the top and the bottom by 4, because I guess I'm going to need a 12 down there. So that's going to be 1/12. This right here is going to be 8/12, and so added up together, those will be 9/12, and I know in the back of my brain that that reduces to 3/4. But I'm not going to get ahead of myself yet. Let's do this one as well. I'm going to multiply that by a 4, and I'm going to multiply that one by a 4, because that's going to give me a 12 on the bottom. So I've got plus 1/12 y, plus 1/12 y, and then I've got a minus 4/12 y. Well, this has been fun. That's 9 over 12. 1/12 take away 4/12 is negative 3 over 12. We just took the 1, take away 4. Negative 3 over 12, and that's a y. And I know that if I multiply both sides by a 12 now, I've got a denominator of 12. Isn't that convenient? We'll cross those off. And I just have negative 3y equals 9. So we'll divide by a negative 3, and we'll get y equals negative 3. Wow, that was a lot. So y is negative 3. Let's go ahead and build that as part of our ordered pair solution. So now that I know y, I'm going to plug it back in and find x, and the one that makes sense, I guess, is to plug it to the bottom one. So 1/6 x minus 1/3 times y, and y is a negative 3, so that's okay. So I see that my fractions are going to go away. 3, 3, those turn into 1s, and the negative times the negative is a positive, so that just becomes plus 1 equals, and I just got 2/3 over there on the bottom. So if I take a look at this, I got 1/6 x plus 1 equals 2/3. Well, gosh darn it. Take away a 1. I'm tired of fractions, honestly. 1/6 x equals, now might as well change this negative 1 into negative 3/3, because that's what 1 is, and 2/3 take away 3/3 is negative 1/3, And then our last step is to multiply by 6, and we're going to get rid of that, and we're going to learn that x equals negative 6 divided by 3, which is a negative 2. So that's one way to do it, where we're only looking at the fractions, and in a minute I'm going to show you one where we're going to clear all the fractions. Okay, in this problem, every denominator is a 2, and every denominator on the bottom is a 2 also. So what we're going to do is we're going to take and we're going to multiply the bottom one and the top one, both of them, by a 2. And what that's going to do is it's going to get rid of all these fractions, because if I multiply that by 2, each of those are going to turn into 1s, and that's going to turn into a 1 also. So I don't actually have any multiplying to do. All I have to do is cross off some denominators. So this 2, and this 2, when they all get multiplied by 2, everything just turns into a 1, and I just have to rewrite what I got minus the fraction. So it's minus 1x, I'm going to put the 1 there this time just for fun, plus 1y equals, and the 2's are gone, and the 1, but it's still a negative 3 on top. So there's one equation, and this one over here is 1x plus 1y equals 5. And look at that. I already have something that's going to go away. Negative 1x and a positive 1x are going to turn to 0 x's. So there's 0 x's, there's 2 y's, and that equals 5 take away 3 is 2. And so when we divide by 2, y is 1. And, you know, we're probably not supposed to do this. We're usually supposed to substitute it into one of the original equations. But you know what? I'm going to reward myself because I don't like looking at fractions. So I'm going to go ahead and substitute it into this bottom equation, even though I've already changed it. It's not the best practice, but I know that I was okay to get rid of all those fractions. If you make a mistake when you turn one equation, if you make a mistake when you go this way, plugging it into the wrong equation will give you a wrong answer. But I'm going to put a 1 there in place of y. That's a 1, so that's going to be 1x plus 1 times 1 is 1 is 5. And when I take away a 1, I'm going to get x is 4. And there's my ordered pair, 4, 1. And that's it.